Let me ask you something. What if I told you there's just one single formula that can find the volume of pretty much any prism you can think of, no matter how wild or weird its base is? Well, today we're going to dive into that master key of geometry. So, right out of the gate, here's our challenge. Take a look at this thing. It's a prism, sure, but its base is a kite. I mean, there's no volume of a kite prism formula you learned in school. So, where do you even start with something like that? And here it is. This is the only tool we're going to need. V equals B times H. Simple, right? But here's the catch. The real trick, as you're about to see, isn't remembering the formula. It's figuring out what that capital B, the area of the base, actually is. Okay, before we try to tame that crazy kite shape, let's warm up a little. We're going to see how this formula works on a shape we're all familiar with, and I'll show you how we can bend it to our will. Check this out. It's kind of like a little magic trick. If you take any old triangle and make just two very specific cuts, you can actually rearrange those same pieces to build a perfect rectangle. And here's the big takeaway from that little demonstration. We didn't add anything, we didn't take anything away. All we did was move the pieces around. That means the area of that original triangle is exactly the same as the area of the rectangle we just made. This is the foundation for everything that's coming next. And this is where it gets really cool. If we take those two bases, the triangle and the rectangle with the same area, and give them the same height, we turn them into prisms. And guess what? Their volumes have to be identical, because the base area, B, is the same, and the height, H, is the same. So V equals B times H gives us the exact same answer for both of them. All right, so now we know that we can mess with a shape without changing its area. With that powerful idea in our back pocket, I think we're ready. Let's go back and finally face that kite. For a basic shape like a square or a triangle, finding that capital B is a piece of cake. But our kite, there's no famous area of a kite formula. So how in the world do we find B when the base itself is the whole problem? The answer, you'll be happy to hear, is actually pretty simple. It's a technique you can use for almost any complex shape you encounter. The secret is, you don't have to measure it all at once. You just have to break it down. This right here, this is the golden rule. Any complex polygon, it doesn't matter how weird and intimidating it looks, can be broken down into shapes we already know how to measure, simple rectangles and triangles. That's the whole strategy. And just like that, the problem becomes, easy. See? That big, scary kite shape is really just two ordinary triangles stuck together, and we absolutely know how to find the area of a triangle. Okay, let's run the numbers. For that first bigger triangle, we just use our standard formula 1/2 base times height, and that gives us 180 square inches. Then we do the exact same thing for the smaller triangle, and we get 36 square inches. So all we have to do now is just add them up. And there it is. We found it. We found our capital B. The total area of that complex kite base is 216 square inches. And believe it or not, the hardest part of this whole problem is officially over. All right, now it's time for the victory lap. We have our B, we already have our H, and we have our universal formula. Let's put it all together and get our answer. So we go right back to our trusty friend V equals B times H. We plug in the base area we just worked so hard to find, 216 square inches, and we multiply it by the prism's height, which is 3 inches. And bam! 648 cubic inches. That's the volume of that strange-looking prism. By breaking down the problem, we made it totally simple. And this method, it'll work every single time. So you might be thinking, okay, that's a neat math trick, but why does this actually matter? Well, think of it this way. That prism's base is like an oddly shaped floor plan for a house. You can't measure the whole floor at once, right? So you find the area of each room separately, the living room, the kitchen, and then you add them all up. That's your total B. Then you multiply by the ceiling height, that's your H, and now you have the total volume of air in the entire house. It's a really practical skill hiding inside a geometry problem. So the next time you see a complex object, maybe a weird piece of furniture, part of a building, or even a swimming pool, remember the power of breaking it down. Just look around you right now. What's a shape you see every day that you could now finally figure out the volume of?